So as I said, it's wonderful to have you all here. The aim of this afternoon is to work on some problems together from the latest primary feature on NRICH, and we'll do some mathematics together, but we'll also think about how you can use the tasks in your classrooms and the sort of mathematical thinking that we hope your students can become engaged with. Throughout the event, we'll be asking you to participate via the chat, as you already have. It sometimes makes things easier if we can refer to you by name. So if you don't mind, it would be really helpful if you could rename yourself if you're not happy with the way that your name is currently displaying. And you just do that by clicking the 3 dots on the little rectangle where your video would appear. That just makes our lives a little bit easier. So thank you. We'd like to remind you you've agreed to abide by our code of conduct in joining us, so please be respectful, and I'm sure that we'll all enjoy doing some maths together this afternoon. So I'm now going to stop sharing this PowerPoint, and instead I'm going to share the NRICH website. Charlie, would you mind nodding or saying yes if you can? You see the NRICH homepage? Brilliant. Okay. So our intention this afternoon is that Charlie and I will have a little chat about the primary problems, and we'll involve you in some of the mathematics. Some of you may well be very familiar with NRICH and others of you may not. So what we're going to do is we'll sort of do a little bit of general navigation, but we'll try not to dwell too much on that for those of you who are familiar. So this is the NRICH homepage, nrich.maths.org, and as primary practitioners, I would suggest that the best place to be your go-to, if you like, is the primary teacher homepage, which you can find by clicking on this button right on the top black bar. That black bar remains on every page on the NRICH site, so it's quite handy to become familiar with it. For the purposes of the majority of this afternoon, we're going to be looking at our current feature, which you can find linked in this blue box on the right-hand side. By a feature, we just mean a collection of tasks and perhaps an article or two, all grouped on a similar theme. So here we go. This is the current feature. As you can tell, it's called Exploring Factors and Multiples. And just before we do any maths, as a quick overview, what we've tried to do here is gather tasks together that we hope will give children the opportunity to play with numbers, and in particular with factors and multiples. And we hope by doing that, it'll build their sense of number, that feel for number, which is so key to being a great mathematician. We're going to look at a number of tasks from the feature. Before we do that, Charlie, is there anything that I haven't sort of said in that overview that you think would be worth saying?
I suppose just to clarify, I may seem a bit ignorant throughout our conversation, and that's because Liz is responsible as the primary coordinator. So I've seen these problems, but I haven't looked at them in any detail. So I've been working on the secondary problems. So this is a genuine conversation, me asking questions that I don't know the answers to.
So anything you'd like to ask at this point, Charlie?
No.
Okay, great. So we'll you can see just if I scroll down this page as giving you a quick flavour of what's in the feature, that each of the resources here has got its own little icon and it's an age label. So we're giving you a suggested age range for using the task. This resource in the top left is an article written by Ems, which accompanies the feature and gives you a bit of a narrative about why we've chosen these particular tasks. So do take a look at that after the webinar this afternoon. You can tell that the tasks are ordered roughly in terms of age. And so we're going to begin at the first task, which is called Using Books. The doorbell rang, and you'll notice that it's got an early years icon. I'm going to click on that. Now, some of you may be early years practitioners, some of you may be responsible for mathematics in your school. If you didn't know, we do have an early years area of the site, which you can access from the top menu, just as you can the primary teacher homepage. And this is an example of one of the activities. Because of its nature, we're not going to do this activity together, but I just wanted to share it with you to give you an idea in case you didn't know these kind of activities exist. So it looks a little bit different from the rest of the NRICH site. The entire resource is written with the practitioner in mind. So this is for the practitioner to read. You could print it off and have it with you in the setting. And all our early years resources have the same format. So we talk about, you know, something that children often enjoy, the hook to the mathematics, if you like, and what an adult might do to, what's the word I'm looking for, to bring out the mathematics, to encourage the mathematics. This particular task involves around a picture book, which is called The Doorbell Rang. Many of you may know that. So what we've done here is we're suggesting some questions and some prompts to encourage mathematical thinking and reasoning that you could use having read the story with the children or while you're reading with the children. I'll just scroll down so you get a flavour of the kinds of headings that we're using there, which are the same throughout our early years tasks: describing, reasoning, opening out, recording. We give you a little overview of the mathematics that the children might encounter as they have a go at the activity with you, and some ideas of how you could develop the theme. You can see there that we've got a couple of other tasks which are also storybook linked, if you like. This particular task very much focuses on sharing, which is a really lovely way to encourage children to start thinking about factors and multiples. I think it's natural for us, isn't it, almost, to want to share things equally, and children, that is a fantastic way of drawing children in to this kind of mathematics. Charlie, is there anything that you'd like to ask about this early years task or the early years resources in general that I might not have mentioned there?
I know that Cherry Mosley did quite a lot of work on books and maths, and I know Cherry has done some work for us. Is there somewhere where teachers can find other examples?
So that's a really good question. So in addition to the two NRICH tasks, which are linked right at the bottom of here, so these are NRICH tasks which are also based on stories. We are in the process, it's a kind of a watch this space answer. We're in the process of creating a page, a sort of a top level page of the NRICH site, which recommends storybooks, thinking about the sort of picture books, thinking about the younger age range, but also books for older children too, through which you could do some mathematics. So we're in the process of getting that ready, Charlie. Thank you for asking about it. I'm not going to give a URL yet because it's not quite ready, and I prefer to launch it when it's up and ready to go. At
our next webinar, perhaps.
Good point. At our next webinar. So watch this space would be my response to that. Anything else, Charlie, that you think? If you have any particular questions on the chat, do feel free to post on the chat. We'll do our best to answer questions as they come up, but of course, I'm sort of hoping that maybe Ems might be keeping an eye on it, and anything that we do miss, she could always mention towards the end of the webinar, and we can try and answer for you. Okay.
If you just don't have a copy of the book, I know that there are sort of online versions, aren't there? Are there links to this in the problem? Or
yes, there are. If I scroll down a little bit, in the suggested resources section, there's a link to a YouTube version. Somebody's reading it on YouTube. Yeah.
And I could imagine the nice thing about that is being able to pause and ask questions. I'm imagining, because it's about a couple of children and then their friends turning up, and
that's right.
The mother having 12 cookies or something.
Yeah.
And I could imagine pausing and getting them to, and thinking, oh, how many children would it be okay to arrive? There are lots of questions that could emerge.
Oh yeah.
while reading. Or watching the story.
Absolutely, absolutely. It's a wonderful book for that. And I think children become really quite hooked in. So yes, if you didn't have a copy yourself, it doesn't mean you cannot have a go. Yeah.
And presumably as an extension, they could write sort of variations on it, which don't involve having 12 cookies.
Absolutely. I mean, it's interesting that, yeah, the number 12 is being chosen quite carefully. And, as you read this story with a group of children, I think what's quite interesting is when that specific number 12 is noticed, and it's often, I think, a child who might point that out, and it can lead to some lovely conversations about, well, what other number of cookies could we have? Why do you think the story is about 12 cookies? Why has Pat Hutchins chosen 12 cookies? Yeah. Okay. Let's go back then. So that was one of our early years activities. It occurs to me that, having said, please post your questions on the chat, I can't actually see the chat. Now I can. So let me just double check there's nothing that's come in. Oh, great. So a couple of people have used the book. Fantastic. That's great to know. Thank you for sharing your experiences. So Charlie, that was an early years activity for sort of the youngest children. The next task I'd like to share with you and with everybody participating is this one here. It's called Tables Teaser. So this one is for slightly older children. We're suggesting Key Stage 1. By the way, you'll also notice that our activities are labelled with this challenge level, either 1 star, 2 stars or 3 stars. And by that, we're giving you an indication of how easy it is to access the problem in terms of the problem solving skills. So I would expect a 1-star problem would be really suitable for a whole class. Most children in a mixed attainment class will be able to get a good way through that task, as opposed to perhaps a 3-star problem, which you might offer children who perhaps have had more experience with problem solving. So it's particularly giving you an indication of the problem solving level, if you like, as far as we can. So here we go, Tables Teaser. Let's have a look. So here's a grid. Charlie, what do you see here? Yeah, your microphone.
So this seems like a conventional times table, except that it doesn't have all the numbers from 2 to 10 or 2 to 12. It's just got some selected numbers for the column and the row headings.
Okay, yeah, absolutely. And I think that, given the fact we're all practitioners, when you say conventional tables grid, I think we all know exactly what you mean. So I'd like to offer you an interactivity here, Charlie. So rather than having a grid where I might have given you some numbers along in the headings, if you like, along the row at the top or the column down the very left, and ask you to fill in the grid. Instead, I'm going to do something a little bit different with this interactivity. This Tables Teaser challenge only involves the tables 2, 5 and 10. So just bear that in mind. And what we're going to do is we're going to choose a cell to reveal. And by revealing, if you like, the products from the grid, we're going to try and work out what the factors are, in other words, the numbers at the top and the far left-hand column. So Charlie...
Can I just check, Liz?
Yeah.
I seem to be offered options from 2 to 12 rather than 2, 5 and 10.
That's a really good point, Charlie. You are, because what you might find is, even though we're working on the 2 times table, we are going to be challenging you to know what 12 times 2 is, for example. Or we might want you to know what 7 times 2 is. You're looking confused still.
Okay. Okay, so do you want me to choose a cell to uncover?
Please do. Which cell would you like to uncover first?
Okay, top row, second from the left.
Top row, second from the left. Is my pointer visible to you?
Yes,
Is that the right one?
it is.
Great. 50. Okay. So what?
So presumably, I don't know whether the 5 is the heading for the row or the 10. So
Hang on a sec, Charlie. Whoa, slow down. What's this about 5 and 10?
okay, so 5 times 10 makes 50.
Yes.
And I can't do, for example, 2 times 25 because 25 is not available. And I can't get 50. I'm not going to do 1 times 50. So I've got to choose 5 and 10. And what I don't know is whether the 5 is my row,
right,
and the 10 for the column, or vice versa. So
okay, exactly.
if I choose another number in the same column, for example, so just below 50.
Yep, this one here.
I should be able. Oh no! That's so unfair.
Oh, that is unfair.
Okay.
What are you going to do now?
Okay, what about the number to the right of the first 50?
Okay. I haven't deliberately done anything here, Charlie.
Okay, keep going to the right then.
Okay. Oh, right. What have we got here? 10. Those of you on the chat, if you've got any advice to offer Charlie, please do chip in. So we've got a 10 there. What could that be then, Charlie? What could the factors be?
I still don't know whether 5. No, I think I do know.
Go on.
Because I'm not offered 1 as a possibility.
Okay.
I think the row heading has to be 5, and then the column headings 10, 10, and 2.
Okay.
It means that the second row will also have a 5.
That's right. Sorry. Yep, absolutely. Okay. Those of you, Sue has asked, can you only use each factor once? Really good question, Sue. No, you can repeat the factor. I should have said that. Yeah. Yeah. Thank you, Ems.
So I don't know. I don't know what the bottom 2 row headings are or the first column.
No.
So I'd be tempted to uncover the cell in the 3rd row, first column.
3rd row, first column. This one here.
Yes.
45.
Okay, so 45. I think the only way getting 45 is going to be 5 times 9.
Yep.
You're not going to allow me 3 times 15.
I'm not. No, we only got to 12.
And because we can repeat 5s, it could be another 5.
It could be another.
So I'm not going to know until I uncover either the bottom. Well, I want to know what the bottom row is. So I'd go for, I'd uncover the number below 45.
Right. 90.
Okay. And I think this tells me that the column heading must be 9.
Okay. So let's pop 9 in here.
And I'll do the easy one first. The bottom row is 10.
Okay. 9 10s are 90. And here we go. 9 5s are 45. Now you might notice as we've been doing this that on the left hand side here, it's telling us we've got 4 reveals left. We had 10 reveals at the start. So what the interactivity was saying to us, you are allowed to reveal 10 cells, but no more than 10 before you can see the solution. So are we happy that we should see the solution? Charlie, you happy?
I'm reasonably confident.
Yeah, I think our reasoning is quite sound, isn't it? So I'm going to click here where it says show the solution. Oh, look, we've got 8 smiley faces. Now, what you can do with this...
9 smiley faces. I'm smiling as well.
Very good, very good. You can, if you click here on the purple cog, but if you're relatively new to NRICH, when we have interactivities in NRICH, we often have this purple cog, which allows you to change the settings. So if you want to, you don't have to limit the number of reveals. So you could choose it for it to be 12, 14, or unlimited. So that's just, we gave you a challenge. We gave you a challenge of 10. I'm going to leave it at 10. You could use this activity. What you might want to do is you might want to challenge students to choose as few reveals as possible. For example, is it always possible to be able to complete the grid in, let's say, how many did we have left? We had 4 reveals left. So we revealed 6 numbers, Charlie. Do you think, I wonder, whether we could have done it in any fewer than that? I think I might be being a little bit unfair to expect you to answer that straight away without having more time to play around with the interactivity. And that's something that children will definitely need time to have a go. What you could do is encourage them, if you're lucky enough to have tablets, for example, or access to computers, you could encourage them to be working together so they can talk through their ideas as they try to complete this tables teaser grid.
So I'm imagining, Liz,
yes,
that if you uncovered everything in the top row and everything in the first column, I'd be able to tell you what all the headings are.
Okay, and why are you so certain of that, Charlie?
Because if I reveal all 4 in a row,
yeah,
I'm imagining I'll have enough information to work out what that row heading is. And once I know what the row heading is, it tells me what the heading is for all the columns. And it doesn't have to be the first row on the first column, just one whole row and one whole column would do it. But that would involve uncovering 7 cells. So I think for me, what I don't know is, can I consistently do it in fewer than 7? So
yes.
I mean, do you want to just uncover one whole row and one whole column? Just so.
Let's do that. There's a row, and let's do this column.
So that row are all multiples of 5, and so I can then label that row, and then I can label all the columns accordingly.
Yeah.
And because I know that that column is 10, I can then do all the rows. So 7, I'm convinced. What I don't know is whether one can find an alternative strategy. I'll have to go and think about this to guarantee, for example, that you can always do it in 6.
Which is what we did. So were we lucky, or is that always going to be possible? Is what you're saying? I completely agree that we'd always be able to do it in 7. Okay, let me see. Let's talk. What am I trying to do? I'm trying to do this as I talk, which is never a good idea. I think I've completed that correctly. 10, 4, 5, 2.
Can I just check, Liz?
Yeah.
At the beginning, you said something about 2s, 5s, and 10s.
Yes.
But there isn't. Is that information just above this interactivity? Because the interactivity itself doesn't say that.
You're right, it doesn't. That information, that's a really good point. That information is not above the interactivity, but I think it might be in the teacher's resources section here. You're putting me on the spot now, Charlie. Yes, it's in the teacher's resources section.
Okay.
Yeah. Do you remember that all the NRICH tasks have teachers' resources, which can give you ideas about how you can use them in the classroom? And you can see this first heading, why do this problem? What is the mathematics of this problem? Why bother using it in the first place?
And there are variations on this, aren't there? Which
that's right. So we've said this only involves the 2, 5s and 10s times table, but there is an activity called Mystery Matrix, which is enrich.maths.org/ I made a note of it, /1070, which is exactly the same premise, but that uses all the multiplications from 2 up to 12. So.
And would you mind just adding that to the chat, just in case? Or is there a link to it in the teacher's resources, Liz? Sorry to keep putting you on the spot.
Yes, there is. There's a link to it in the teacher's resources.
Okay.
There we go. So I think
that does all the multiplication tables from 2 to 12, does it?
All from 2 to 12. Yeah. Yeah. So that's the only way that they differ. They're exactly the same premise.
And presumably, so I can imagine 2 children sitting at a computer in a classroom using this, but if in a classroom, if teachers don't have tablets, laptops, whatever available, I could imagine playing. Oh, you told me what's the game where? So I could make up my own times table, and you could make up Battleships. It's called. That's the game I'm thinking about. So I could make up a times table myself, and we could agree which times tables were allowed, and then we could each have an empty grid.
Yes.
And try and work out the column and the row headings of our partner while they try and work out. And I suppose the challenge would be, can we do it in fewer guesses than our partner?
Yeah, absolutely. Or you could even do that, I guess, one pair working against another pair. So that with a partner, you're creating a grid for the other pair to complete. And then you've got somebody to talk with. So to reason, I guess. Yeah.
And I suppose, I mean, one of the nice bits of reasoning that might come out of there is, for example, not to have sort of 5 times 5, 25, because when you have 25, there are,
immediately.
I was having trouble.
Yes.
I can imagine when you're doing other numbers like 12. Oh, is 12 2 times 6 or 3 times 4?
Yes.
And is the 6 at the row or is the 6 at the column? And lots Absolutely. Of that's really awkward. But a number like any square number, well, no, because 16 could be 2 times 8 as well as 4 times 4. There's lots of interesting.
There are lots of interesting conversations.
Questions.
Yeah, absolutely. And some of those interesting questions are written here in the actual text of the problem, and some of them you'll find in the teacher's resources section, where there are key questions and extension and support ideas. So yeah, thanks, Charlie. I think then I'd like to show you one of another task that's in the feature. So I'm going to go back through here. Actually, it'd be easiest if I go to the home page again, I think. I can't remember how many times I've clicked away. So that one was Tables Teaser in our Exploring Factors and Multiples feature. I'd like to now show you Dicey Array. And Charlie, I think we've probably done a bit too much talking. And I reckon I'm going to invite our participants to have a think about this. So this is a game. And rather than me telling you the rules of the game, what I'm going to do is I'm going to show you a brief, the start, if you like, of this video of 2 people playing the game. So it's a 2-person game. I'm only going to show you the very first player, the first player's turn. There's no sound on the video, so don't worry about that. And while you're watching, I'd like you to think about how you think you play. What do you think the rules of this game could be? Let me make this bigger. So that's a 7 and a 1 that's been thrown on the dice. So that's all I'm going to show you at the moment. I wonder whether you could pop in the chat any of your thoughts. What do you think the rules of this game could be? Or maybe you have some questions because you've only seen the very first move. Pop your thoughts in the chat, please. Thank you to those of you who've posted your thoughts. We seem to have agreement. Sorry, I'm reading and talking at the same time, which is never a good idea. I think, Charlie, there, we had agreement that we were adding the two numbers on the dice. So we were adding what we'd rolled. And then you've got different ways, had slightly different ways of phrasing this, which is helpful, I think. Creating arrays from those numbers. I like that. That's what Sue says. Tina there has said that the dice, the 1 and the 7 was an 8. And so the player was, you had to make multiples and use the counters to display this. Right, so there's something about creating arrays, rectangular arrays with that number of counters. I think somebody phrased it. Emma says, add the dice together, find the factors.
Yeah.
Sorry, Charlie? That's what
you're I was going to say, Emma mentioned factors.
Yeah. Okay. Laura's mentioned how many possibilities can be found. Right. Okay. So there's something here about, can we find all the possibilities? How many different arrays can we create if we're with this total number that we've thrown? How many ways can you create the product using arrays? So Kristen, thank you. Yeah, the different factors. Okay. What do you think the significance is, Charlie, about the target 10 at the top? Sue. Oh, Sue's a mind reader. Remember, the target is 10. How are we going to reach that target then, Charlie? Any ideas, or anybody else participating?
Well, I noticed that I'm not quite sure what to call A, but
so I can reveal that. So L is me, Liz. A is my daughter, Amy. So you can refer to her as Amy, should you wish.
Okay. So Amy wrote a 4 at the end, and I imagine that's because she found 4 different arrangements for the 8 counters, and she's hoping that you're going to get a total which is a prime number, and you're only going to be able to get 2 arrays, and then it'll be her turn again, and presumably the target 10, meaning you carry on until one of you has found 10 arrays.
Exactly. And I can see that between Emma and Sarah and you're suggesting that. Exactly right. So we're going to keep a running total that Sarah said. Okay, so Amy, player A, if you like, she scored 4 so far. It would be my turn to roll. I'll create as many different arrays as I can and note down how many. Then it'll be Amy's turn again, and she will add on the number of arrays she gets in her second go to the 4. And whoever gets to 10 first, as Kristen said, will be the winner. So Charlie, you mentioned prime numbers. Let's have a think about that. Those of you participating on the chat, which numbers then are we going to want to roll and why?
Liz, before we do that, do you want to just click on the cross at the bottom of the video? So it just feels like a distraction.
Yes.
Claire and me.
Yeah. Good point. In fact, I'll shrink this back. Yeah. Thank you. Yes. Sue suggested 12. So Sue's suggesting that 12 is it could be a useful number to make as a total. I wonder why. And are there others that we would like to aim for? Just to clarify, the dice that we're using in the video is 0 to 9 dice. I'll leave you a little minute to think about that. So Sue, I agree. You've got you've listed there 6 possible arrays, I think, for throwing if we got a total of 12.
If you've got dice 0 to 9 dice, I think there are just 2 numbers, 2 totals that give you 6 different arrays. So I imagine Amy would be hoping for those. 12 is one of them.
12 is one of them. I wonder what the other one is. Do post if you have any suggestions about what the other total could be that gives you a 12, that gives you 6 possibilities, I beg your pardon. Just like 12, we could get 6 possibilities, 6 arrays.
And there are some numbers which only give you 2 arrays.
Yes.
I imagine Amy's hoping
that I would roll.
You're going to roll.
Exactly. And you've hinted at that, more than hinted at that already, I think, Charlie. Yeah, that's great. 20, Kristen, is that so? To 20, we would get 1 times 20, 20 times 1, 2 times 10, 4 times 5. Yes, you're right, Kristen. Yeah, I'd forgotten about 20. I'd noticed.
Well, only if you're using dice which are 1 to 10 rather than 0 to 9.
Beg your pardon. No, Sue's right. Yes, no. So we couldn't with a. I fell into the trap too, Kristen. Don't worry. Yeah, having tried to emphasise the numbers on the dice, I then immediately forgot. So yeah, okay. Now in the classroom, of course, I would imagine it would be a great idea to take your time watching the video. I have been, very cruel to you. I've only offered you the first player's turn, so you may want to play the whole video. In total, there are 3 turns on the video. So you may want to play the whole video all the way through to start with, and then pause it, give children time to talk to their partners about what they think the rules might be. And then you can talk in the same way that, that we've done to clarify the rules. You can see on the problem here underneath, if you click on this show button, we've actually written out the rules for you, just in case that's helpful to have them written there. And of course, not everything is apparent from the video, so children will have questions and they won't be able to tell from the video exactly what the intended rules were, and that gives you a good opportunity. Having played the game using the NRICH rules, if you like, then we could think about tweaking. So how could we tweak this game? What could we do differently? One thing that springs to mind immediately is increasing the element of choice. So rather than, for example, having to add the 2 numbers that you roll, what about being offered the opportunity to subtract one from the other on your turn? Sometimes that may increase the number of arrays that you can draw. I wonder what else you can think of that ways in which to tweak the game. We could include other operations. We could use multiplication, for example.
And I suppose if you had 3 dice rather than 2 dice, and you had to use, say, 2 different operations, but you could choose which 2 operations,
Right.
there'd be a lot of thinking about all the different possibilities.
Exactly. So this task is great for thinking about finding all possibilities and working in that systematic way. Sarah, sorry, I don't think I can't have explained very well what I meant. What I meant was, when you, on your turn, you roll the 2 dice, and then it is your choice. Do you add the 2 numbers together and you make that number of arrays? Sorry, do you make arrays of that number? Or do you choose to subtract one dice number from the other? So let's say I throw a 5 and a 1. I might decide to add those 2 to make 6, and then I'm finding all the arrays of 6 counters. Or do I subtract 1 from 6 and find all the arrays using 5? And if my aim is to be the first to get to 10, in that example, I'm guessing I would add the 2, because I'll be able to create more arrays with 6 than I would with 5. I hope that's made it slightly clearer. Don't forget that all of the tasks that we've looked at, oh no, not all of the tasks we've looked at so far, but 2 of the tasks we've looked at so far are live problems. So what we mean by that is that actually we don't publish the solutions at the moment, but we're inviting your children to send their solutions to us. So on the left-hand side here, you'll see, as well as the Teachers Resources tab, you've got a Submit a Solution tab. And if I click there just briefly, you can see that there's a bit of information to fill in, and then you can encourage your students to explain what they've been doing, how they know their solution is correct, what they've found out, or you as the class teacher could summarise what your class have been doing. You can see that there's an article linked here about what we look out for, and we're particularly interested in well-reasoned solutions, not just answers. And you've got until the 17th of May to submit solutions to our current live problems. I think I'm quite keen to have a go at one last task before we finish, Charlie. So I'm going to close that down. Here is our feature again, and here's the last task that I'd like to have a little look at. It's called Dozens. But rather than show you the task on the website, before we do that, I'd like to introduce it to you using some digit cards. So this is where I have to learn to read digits the wrong way around. So here I've got 2 digits, a 2 and a 5. My challenge, Charlie, to you is to use these 2 digits and one other digit of your choice to make a 3-digit number that is a multiple of 2, so an even 3-digit number. You must use the 2 and the 5, but anything you like as well, another digit. What might you do?
So I could add a 6 at the end. Presumably I can put my extra digit anywhere I like.
You can indeed. You could put it, so you could keep those 2 like that. Okay. So you added the 6 into the
256, or the 2 that you have in your right hand could go next to the 6, and we could have 562. And presumably we could also have 526.
All of these are even numbers. Yeah, all multiples of 2.
And we could have the 6 in the hundreds column and have 652.
Indeed. Brilliant. So you happen to choose a 6 there, Charlie. I can see that Neelam has suggested that you could have instead chosen a 0. So he's suggested, I think it was, I've lost it now.
250.
Thank you very much. It's just gone out of the chat window, I can see. 250. So that's another possibility. And
Tina has suggested we could also use one of the numbers that we already had and repeat it, and that's allowed.
Absolutely, we can repeat a number. I'm just finding another 2 to use. Yep, definitely. So we can repeat digits, that's not a problem.
So we could have 252. We could also have had 522.
We could indeed.
And presumably we could have repeated a 5.
We could repeat the 5 instead. So we could have
had 552.
Exactly.
Okay.
Like that. Okay, so that's the idea of this task, but I'm going to introduce you now to the interactivity that we've got on the site. This is called Dozens. So the task is enrich.maths.org/dozens. let me show you the interactivity. This is giving us, it's giving a little bit of a twist on what we just done, Charlie. It's making it slightly harder because this time we've got to use the 2 digits that the computer offers us and one of our choice, but we're trying to make the largest possible multiple of 2. So I wonder whether you could make some suggestions on the chat. We have to use the 0 and the 9. What digit could we use with those 2 to make the largest possible 3-digit multiple of 2? Perhaps you could post some suggestions. Okay, thank you. We've got a couple of possibilities. Should we try, let's try, we've got 900 and, let's try 960 first, shall we? So if I pop 960 in here, 960, if I click on check, okay, so the feedback I'm being given is this is a multiple of 2, but there is a larger one. So I wonder, we'll click try again. Let's try, should we try 990? I can see some of you have suggested that. That's the largest one I can see that's been suggested. Let's check that. Great. So that's the largest multiple of 2. So we could have a little go at this, but I wonder actually whether multiples of 2 are a bit too straightforward for us, Charlie. Let's have a little go at multiples of 3. So I'm going to click at the bottom here and set up a new challenge with multiples of 3. How are we going to know, Charlie, that a number is a multiple of 3?
Well, the rule that I know is that if you add up all the digits and the sum adds to a multiple of 3, then the number's a multiple of 3.
Okay, yes. That's the rule that I know too. So we can add up the digits, and if we get a multiple of 3, we know that the 3-digit number is a multiple of 3. Okay, so we've been given a, sorry, Sarah, yes, we can repeat the digits. Just like we could with the cards, we can repeat the digits. So we've got a 2 and a 4, and we are being asked to use the 2 and a 4 and another digit of our choice. This time we've got to find the largest multiple of 3. Remember, we must use the 2 and the 4 as digits as well. So have a little think about that one. Okay. So we've got quite a few people suggesting 942. So let's have a think about that one. 942. So if we add those digits, 9 plus 4 plus 2, 8, 40, 15. Yeah, I agree. That's a multiple of 3. So definitely a multiple of 3. We've used the 2 and the 4. So let's check. Aha, brilliant. Okay. So we've got the largest possible multiple of 3. I'm sort of tempted to ramp it up even further, Charlie, just before we round off. You know, it's almost 5 o'clock, but that's okay. I think we can cope. Should we try multiples of 6? How are we going to know, though, whether a number is a multiple of 6? I wonder whether you might suggest in the chat. What do we know about multiples of 6? Okay, so thank you. Rashmi is suggesting that a multiple of 6 is a multiple of 2 and a multiple of 3. Absolutely. So Sarah says an even number whose digits add up to be in the 3 times table. Absolutely. Just a different way of saying the same thing. So, oh, Neelam is jumping in already. Okay, so we need to use a 1 and a 0. and another digit of our choice to make the largest possible multiple of 6. I appreciate I'm not giving you very long to think about this, so sorry. Yes, don't forget we need to use the 1 and 0. It is easy to forget, isn't it? We get excited. Okay, let's try this 810. A couple of you have suggested 810. So 8 plus 1 plus 0. We've used the 1 and the 0. 8 plus 1 plus 0 is 9. So it is a multiple of 3. It is even. So that is a multiple of 6. Is this the largest? Let's check. Nice. Charlie, do you think we've got time to do multiples of 20 quickly?
Okay, very quickly.
Very quickly. Okay, we're going to up the ante. I'm going to click on the settings on that purple cog, and this allows you to use any multiple. We'll stick with 3 digits for our target number. The computer's going to give us 2 digits, so I'm going to click in the current window. So multiples of 20. What do we know about multiples of 20?
So Liz, just to clarify, so that could have been, this could be used with young students where you just have a 2-digit number and you get given 1 card.
Yes.
Or you could be doing bigger numbers, maybe 4 digits, and you're given 2 cards.
Absolutely, yeah, that's good.
You might want to set up a new challenge with a multiple of 20, just to make it a bit harder for everybody.
Okay, all right, that's a good idea. I'll click here, set up a new challenge. Different one, yes, Charlie? Shall I keep going a little bit and see what we get? That one?
Okay.
All right, let's try that one. Sorry, those of you who are already thinking about it, rather than listening to us waffling on, quite right, get on with the maths. So here we go. A multiple of 20 that uses the digits 9 and 5, a 3-digit multiple of 20. What do you think? Sarah's straight in there. So it's not possible? Why is this not possible? I wonder whether you might be able to offer some explanation. Seems to be some suggestion that this is not possible. Why can't we make a 3-digit multiple of 20 using the digits 9 and 5 and another one? Nice, Sarah and Victoria, you've pointed out 2 important points. I think we know that this has got to be an even number, and we know that a multiple of 20 has got a 0 in the ones column. It has to have a 0, so therefore, as Victoria says, the middle digit must be even. So the tens digit has got to be even. We've got to have a 0 in the units or the ones column. Thank you, Christina. Exactly. And yet we're given 2 odd numbers. So we've got nowhere to put one of these odd numbers, potentially.
Sorry, that was my fault, Liz, being nasty, because initially there was a 7 and a 6, and I thought that was too easy.
Yeah. A lovely opportunity, though, to offer, perhaps we should quickly say, you might have noticed that we've got this option now. I don't think there is such a number. Let's click that. Right, so the computer tells us we're right, there isn't such a number. A really nice opportunity to offer your students a chance to do some quite sophisticated reasoning. And how often actually do we encourage them to reason about an impossible solution? Charlie and I used this task with some year 5 children very recently, and they're quite indignant at first, but I think they got over it.
Can you just go back to the settings, Liz?
Yes.
Just to draw attention to the fact that what's nice about this is multiples. You can type so you don't have to stick to the usual 2 to 12. And of course we did 20. But I think there's, some students might want to start thinking about multiples of 60, for example, and think of them as multiples of 6 times 10, and know the rule for multiples of 6, and know that they've got to have a 0. And there are going to be quite a few impossible cases. And so in that case, you might want a target number with 4 digits, and the computer provides you with 2 digits. And so there are plenty of opportunities. Then it's no longer going to be impossible, but they'll have to do quite a lot of thinking.
That's right. Yeah. Thank you, Charlie. So look, it is 5 o'clock. I apologise that we're going to end up running very slightly over. I hope that you have got a bit of a whistle-stop tour of the activities in this feature. We hope that you've had a chance to do some playing with numbers, and that you've been able to explore some of the relationships between numbers, in particular with factors and multiples. I'm going to go back to share. I'm going to stop sharing the site, and instead I'm going to share the PowerPoint once more, just as we round off. Hopefully you'll be able to take things away to use back in your classrooms. We would love to see you again at a similar event. Do follow us on Twitter if you don't already, and that way you'll keep up to date with what we are up to. Let me click again in here. You may also be interested that we have an email newsletter which goes out roughly every half term, and that's another good way of keeping in touch with what we do. If you didn't know, we have a primary curriculum map. So we take all the objectives from the national curriculum for mathematics here in England, and we link NRICH tasks to them. So if you go to...
Sorry, Liz, should we be seeing a PowerPoint slide right now?
Oh, yes. Can you not see it?
No, I can just see your feature.
Oh dear, sorry about that. Okay, let me try again. Beg your pardon. Thank you for telling me.
Oh, I was so busy reading what was on the chat that I...
No, thank you for telling me. Can you see that now?
Yes.
Oh, sorry. Sorry, I don't know what I did there. Beg your pardon. Okay, so we've got the Twitter handles, the link to sign up to the newsletter. Here is the link to our curriculum map, where we've taken the mathematics objectives from the primary curriculum here in England and linked to NRICH tasks. You can also find links to that on the primary teacher homepage in the top left box. Finally, this, as you know, is being recorded. We will probably early next week put recordings of this webinar on that page on NRICH. So should you wish to share the recording with colleagues or watch it back again, you'll be able to do so. And you will get an email alerting you to that as well. And finally, we're very grateful to Trinity College here in Cambridge for making these events possible by funding us. And we'd be very grateful for your feedback. We do intend to run more of these similar events in the future, but of course we want them to be as useful as they can be. So please do take a moment to fill in that feedback form. And I think Ems has already popped a link in the chat. And apologies for running slightly over, but thank you for your enthusiastic participation via the chat. It makes our lives much easier. And we hope to see you again at a future event. Thank you very much indeed.